Imagine you're a hiker lost in a foggy valley. You can't see anything because you're blindfolded, and all you know is that your goal is to find the lowest point in the landscape. You stand there feeling a bit confused and unsure of where to go next. The world around you is quiet and the hills roll away into the mist. With no clear path, you have to rely on your instincts and senses to figure out how to move forward. This scenario sets the stage for understanding how gradient descent works in a very visual and relatable way. Now, as the hiker, you decide to feel the ground around you. Carefully, you stretch out your foot and sense which direction the ground slopes downward the most. Suddenly, it becomes clear there's a direction where the hill drops off more steeply than anywhere else. In the world of math and machine learning, this direction is called the gradient. It's like an invisible arrow pointing you toward the fastest way down. By tuning into the slope, you're starting to make progress, even though you can't see the whole landscape. The direction clear, the next question is, how big of a step should you take? Imagine two scenarios. In the first, you take tiny, cautious steps so small that it will take you ages to reach the bottom. In the second, you take a huge leap, but you end up overshooting the lowest point and find yourself climbing up the other side. This is where the concept of learning rate comes in. The size of your step determines how quickly and accurately you reach your goal. Too small and progress is slow. Too big and you risk missing the target entirely. Oh, what's the best approach? You repeat the process, feel the slope, take a step in the steepest direction, and then reassess from your new position. Each time you move, you check again for the steepest slope and adjust your direction if needed. This creates a zigzag path down the valley, with each step bringing you closer to the lowest point. In mathematics, the repeated process is called iteration. It's all about making steady progress one step at a time until you reach your goal. Eventually, after many steps, you find yourself at a spot where the ground feels completely flat in every direction. There's no longer any slope to guide you, and the gradient arrow disappears or shrinks to a tiny dot. This is the lowest point you can find in the valley. In machine learning, this moment is called convergence. It means you found the best solution possible for your problem, and there's no need to keep searching. Let's connect this hiking story to machine learning. Imagine the valley as a 3D graph labeled cost function. Your position as the hiker is a dot on this graph, and the lowest point is marked as minimum error. In machine learning, the cost function represents how much error your model has. Gradient descent is the algorithm that helps your model hike down to the lowest possible error, just like you search for the bottom of the valley. All of this can be summed up with a simple formula. New position equals old position step size asterisk slope. Here, your new position is where you'll be after taking a step. The old position is where you started. The step size is like your learning rate, and the slope is the gradient. This formula is the heart of gradient descent, guiding the model to update its parameters step by step until the error is minimized. Recap: gradient descent is a simple yet powerful way to find the minimum of a function. It works by figuring out the direction of the steepest descent, the gradient, and taking a step in that direction determined by the learning rate. This process repeats over and over, gradually bringing you to the lowest point or convergence. The key ideas are the cost function, the gradient, the learning rate, and the final convergence at the minimum. Thanks for joining this illustrated journey through gradient descent. If you're interested in learning more about data science and machine learning concepts, be sure to check out more content from Decode Data Science. We hope this simple guide helps you understand how models learn and improve, one step at a time.